Welcome back. This is the lesson number 7. In this lesson, we are going to study the encryption part of our real ransomware. Here, I have created an empty file. Let's open it in PyCharm. First, I will import the required library. From cryptography.fernet, import fernet, and import os.bash, and import a threading library. I will generate my key by this way. I will get the key from the previous lesson here. Okay. After this, I will type the encryption function. I told you before that I will encrypt small files like text and PDF and documents by specific way, and big files like videos and games and RAR files by another way. The text and documents and PDF, I will encrypt all the data in those files because they are a small size and they won't consume time. But MP4 videos and games and RAR or ISO file is big files, and encrypting all these files will take very long time, so I will encrypt only part of this file. Okay. I will create here a comment. And after this, I will type diff and type encrypt 1 and give it the file name. Okay. And I will put this code inside this function. I have created a comment, and with open file read as binary, here I will replace this by fernet and the key. Okay. With open file name read as binary as alias, I will read whole the file and store it in a variable called original. I've created another comment. I will encrypt the data in those files and put them in variable called encrypted. I will open the file again and write the encrypted data in this file, and I also will rename this file by adding the syllable ransomware to the name of the file. But the MP4 and exe file will encrypt by another way, like we have done in the previous lesson. I will take this function as I type here, put it here, but I will change the comment before this function to indicate that this type of encryption used for videos and exe file. I also this by fernet, and here I will put the key of the encryption. Here encrypt 2. Okay. After this, I will get the function that partition all the hard disk and get all folders and files inside our hard disk. Let's get this function from here. This encryption. I will copy this code and put it here. I will type here a comment called arrays to store the partitions names. I will accept C partition from the encryption process, so I will eliminate C partition from B list, because B list contain all the partitions names in the hard disk, and array contain all files names inside those partitions. I will eliminate the C, so I will type here C and shift the button beside a character and backslash to backslash. Okay. I also wanted to encrypt the desktop. I wanted to encrypt all files in the desktop. So I will create a comment. Let's create this comment called add desktop path to B list. This is the desktop. I will create a variable called desktop. Here are single quotation. Let's get the was of the desktop. Here users, here user, here links, here desktop. Okay, this doesn't work. You can go there and get the desktop bus from here. Here's the desktop bus. And put it here. In some device or some operating system that doesn't have OneDrive, the desktop bus will be like this. So we have two forms for the desktop bus. And because the username is a change, so I will format this name using format function. Dot format. How can I get the desktop username? I will type here BC user name. os dot get login.
خش يا حمام امي. ايه ده؟ الله عليك. مليون مره مفيش حاجه. يلا روح.
os dot get login. It will give us the PC username. Okay, I will put also the desktop username here, and I will test if this to know which username exists. I will test to know which of those buttons is applied in our system. I will type os dot bot dot exists, and I will pass here desktop 1. If this desktop 1 is exist, add it to the vlist. Vlist dot append desktop 1, and the same for desktop 2. I also will create two lists. The first list to store the files, to store the text files and PDF file and Excel file and Word file and picture. And the second list to store games and RAR and MP4 and all videos. So I will create a comment here, listed files array to differentiate between files type, like this. Array 1 to store text and PDFs, and array 2 to store big files. After this, I will call the walk inside partitions in hard disk, like this. If I will call the function list partition, and this function will take a variable which is the path of the file, the path of the folder. And here two lists. The first list contain all extensions of files I wanted to encrypt, and the second list contain all extension of games and videos and MP3 and ISO files I wanted to encrypt. So the first list for documents and the second for big files. I will type here for D and submain and if in os.walk full I. Here is the full path. os.path dot join. I will join the D with the file name. Here there is a file name in F. I will create here a loop to loop through all files names inside this folder F. And here is the file name. I will create a variable called extension to split the extension of the file from the full path. In the full path, dot split from the dot. I want the second part of the splitting, which is the extension. If the extension in the first list, ex list 1, which is represent documents. Append this extension to array 1, which is created for text file and documents. Append the full box of this extension to array 1. If this extension exists in ex.2, append it to array 2. In each folder D, I wanted to create a message to tell the user what he will do to get the decryption key. If you deal with ransomware before, you will notice that all ransomware let a message in each folder of your system tells you what the hackers want from you to give you the key of the encryption process to decrypt your file and return them to their original file. Here I will put this message with open and create a file called important file. Type is text and write in this file this message. Try to create this file. If you can't create this file, just skip. Why I use try and except? Because some folders in your hard disk need the administrator permission, and this can happen with our code. So we skip those folders. I will create the main. Is double equal. I will create here a comment. This comment is calling the walking function that walk through the hard disk and list each type of file in specific array. For each in B list, which means for each boss in the B list, I will create a thread called T1 from the threading module dot thread. The thread function take two parameters. The first parameter is the function you want to thread it. I will thread the list partition. You should eliminate the bracelet, and it takes the arguments that this function take, which is the in and comma. The second argument always empty. Start the thread. Thread start and T1 dot join to make the thread with the following thread until it's executed. After this, I will call the function that will encrypt. So I will type here encrypt 1 and encrypt 2. Encrypt 1 will take the files here. Let's go to encrypt 1 for text and PDF and Excel. So it will take the files from array 1. Where is array 1, which is for text, and also encrypt 2 take files from array 2. So for if in array 1 encrypt 1 for if, and for files in array 2 for if in array 2 run encrypt 2 of if. Here is a problem. You will notice that some files doesn't encrypt, so you will need to use a try and accept. Where you will use it, you will use them before the encryption was. And also here try. And then accept partition, continue. Let's get the code that will change the desktop background. Here is our course. Here is the first ransomware we have created. Let's copy this code, which is changing the background picture from here. And put this code just include this import. I prefer to put this import here. Close this, and you should put the picture, and encrypting the picture, those two files beside your encryption file. So you will go here and just print. I will put or make the encryption of the picture part 3. First, you will need to encrypt the picture to invoke the user and make it unable to see the picture. That's right. Let's see the picture. The picture is encrypted as a database. You forgot something here. Which is calling the function that will change the background. Share process. Here changing the background picture. Change the background. Let's run this code and see the result. Just wait. Here's an important file has been created. Let's wait. Let's see the departition, for example. You will notice that this file has been encrypted. Okay, let's wait. You will notice that also MB3 has been encrypted. Wait some seconds. Okay, it's about to end. You will notice also that our desktop has been encrypted and the desktop picture has been changed. By this, we have reached to the end of our lesson. See you in the next lessons. Because the desktop picture doesn't change as we expect, we should do some modification on the function that change the background. Here I will replace this by this code R and database.gveg, previous by curly bracket, and I will pass to it os.get current working directory. Let's comment all this code and run only the function that change the background. Okay, let's take this function here and call it. Let's run. There is a problem. The problem that this picture should be encrypted. So we should encrypt the picture like this. Just wait. We're encrypting the picture. Let's run it. Okay, the picture transformed to database. Let's run this code again. As you see, the desktop background has been changed to a picture that indicates your personal file has been encrypted, as ransomware do exactly. Ransomware change the background to picture like this and put an important file in each folder of the device. Just tell us the message here. Tell us the message of the hacker. This message is in the important file. In each folder of your operating system, you will find this important file. Here is the important file. Here is the important file. Here is the important file. In each folder of your device, you will find this important file that has the message the hacker wanted to tell to the user, and changing the background and encrypting all the hard disk, including the desktop, including departition, including partition. I accept partition because encrypting the partition will collapse the whole system, and this is undesirable. By this,